Okay, so now we are going to use those covalent dot diagrams and how many bonds an element can make to put some covalent bonds together. So to take a compound and show how it's drawn. So we're going to work on the compound pH3. So once you guys have numbers 1, 2, 3 written down in your notes, I want you to do the drawing with me off to the left side of your notes. You've got some open space there. So the first thing you're going to do is draw the dot diagram for the single atom in the center. So if you're single, you're all alone, it's going to be the element with only one of the elements. So when I look at pH3, my two elements are phosphorus and hydrogen. And I see that there's one phosphorus. I know that because there's no subscript after it, and that there's 3 hydrogen. So since phosphorus is the single one, I'm going to start by drawing that in the center. So I'm going to find phosphorus on my periodic table. And I'm going to find that phosphorus has 5 valence electrons. 1, 2, 3, 4, 5. Okay, so 5 valence electrons tells me that I can make 1, 2, 3 bonds. I can bond on the top, the left side, and the bottom. So our next step then is to draw dot diagrams for the other elements around my center. So instead of that arrow there on each of these spots, I'm going to draw my 3 hydrogen. So I'm going to put 1 hydrogen on the top. I'm going to put 1 hydrogen on the left. And I'm going to put 1 hydrogen on the bottom. Okay. Now my last step is to circle the electrons to show where bonding occurs. So remember in an ionic compound, we used arrows to show the electrons moving, so either losing or coming in to gain. There is none of that. So we're going to show that they're holding hands. And the way that we show they're holding hands or they're sharing is with a circle. So I'm going to connect one of phosphorus's electrons with one of hydrogen's electrons. And everywhere that there's a lone electron, I'm going to circle them to show that now they have a partner. So on my phosphorus, I already had 2 on the right side, so that side is good. And now I have 2 on the top. 1, 2. I have 2 on the left side. 1, 2. And I have 2 on the bottom. 1, 2. And those are going to add up to 6 total. Okay. And then each of my hydrogens has the 1 electron they had, and they get to share the one that is in the circle, which means that each of them have 2. And hydrogen is perfectly happy having 2. Okay, let's try another one of these. I'm going to draw the diagram for CH4. So again, our first step is to draw the lone element. So the 2 elements I have are carbon and hydrogen. Which one is alone? Yeah, that carbon is alone. So we're going to put carbon in the center. And carbon, if we look at our tables, has 1, 2, 3, 4 electrons. So that means it can make 4 bonds. And luckily, I've got 4 hydrogen. So I'm going to put 1 hydrogen in each of these 4 locations. Hydrogen has a 1 valence electron. Okay, my last step then is to circle the electrons that don't have a partner yet. So I'm sticking together my carbon and this hydrogen, my carbon and the left hydrogen, my carbon and the bottom hydrogen, and then this little ugly loopy line here, my carbon and the right hydrogen. So if I were to pick that carbon up from the center and lift it up, those hydrogen would come with it. They're attached now. They're holding hands. Okay, let's try another one. So remember, our first rule is the lone atom goes in the center, but this is chlorine too. It's just one atom. So if you just have two of something, we're going to start by putting them next to each other. So I'm going to put my chlorines next to each other and then find on my periodic table how many valence electrons they have. When I do that, I'm going to find they have 7. So I'm going to give both 7 valence electrons. Okay. And then I want to connect them. I'm going to draw a circle showing that where they don't have a partner yet, they're going to start to share. So on these, my bottom ones are going to share. So now all of chlorine's electrons have a partner. So they're either in the bond with a partner or they already had a partner. This here is called a single bond. A single bond is when 2 electrons are shared. Okay. Let's try another one. O2. So again, I've got one type of element, but 2 of them. So I'm going to put them next to each other. Okay. Oxygen on our periodic table, 6 valence electrons. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay, our goal again is to attach them. So I see right away, bottom needs a partner. So now they're attached, but the question is, are they happy? So what I see is that this electron on my right oxygen and this electron on my left oxygen don't have partners yet. And so I can't be done until they have a partner. My formula says O2, so I can't add anything extra, but I can create another bond. So I am going to circle these left electrons as part of a bond. So now we shared 2 sets of electrons between our oxygen. This is called a double bond. When there's 2 pairs of electrons shared between the same 2 elements. Okay, should we try one more before you guys get going here? We're going to do N2. So again, 2 N's, we're just going to put them next to each other. We've done nitrogen already today. So we've got 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Okay, now we got to get them stuck together. So right away I see top electrons. Now my nitrogens are bonded, but are they happy? I see lone electrons here and here and on the bottom. So we are definitely not done yet. So I'm going to start with my bottom ones. I'm going to circle those. And again, you guys, we still got 2 left. So it looks kind of ugly, but I'm going to loop around here and get those last electrons. Okay. So what I've done is create a triple bond, which is 3 pairs of electrons shared between 2 different elements, between my nitrogens.